Hello everyone, we are continuing this content from the previous video. So in this video, we are trying to learn to create multi-temporal composites. Multi-temporal composites are just the aggregation of all those near real-time images for a longer period of time. So this can be useful for creation of annual land cover maps. So this begins with providing an area of interest. In this case, our area of interest is somewhere in Nepal, that is in Kaski district. And then we provide start and index. And using these start and index and our area of interest, we filter the image collection. After that, we select the level band here and prepare the mode composites by ee.user.mode. And this is just a way to visualize the image. So here we provide the visual parameters. We have minimum and maximum, that is our 9 bands. And this can be added as the layer. And here we can see that the image has been clipped for our area of interest. Similarly to the previous video, we can create probability hillset composites. So these are just the ways to utilize the probabilities levels in each landuse class for the better visualization with more and richer information. So we select the probability bands. These are just the other name for land use classes. So we select the bands from the image collection, dynamic world. After that, we here create an average of those pixels done by ee.user.min. And here we are changing the projection. This is mentioned in the tutorial. So this video is being adapted from the tutorial available from Earth Engine tutorial. And as mentioned there, this projection is better for the visualization in the map section. So the default is WGS84, the default projection, but this one is suggested. And for creating the probability hillset, this is similar to the previous video. Here we are just using that maximum pixels for each class from that mean images we created before, and then we make sure that this can be utilized in the algorithm. For that, we are multiplying it by 100 and as an integer. So this is for the algorithm, and that can be now fed into this algorithm e.terrain.hillset, and we are dividing it by 255 to reconvert it into 0 to 1 pixel values. And that result is multiplied with the image here, and that image is also prepared here. So by dividing 255, so these two are multiplied to create the probability hillset image. And this can be visualized with map.addLayer, and here we are clicking for our area of interest. So the images can sure be exported from the Earth Engine. So this is the export.image.to-drive. This is the function within Earth Engine, and we provide here the image name. Some description can be provided. This is our area of interest, the scale, and the maximum pixels. So this can be repeated to both the hillset composites as well. And this is it. So we run this. So this is the case for our country, Nepal. So we can see here, this is the boundary. This is the boundary here. And then comes the smooth layer. The classification is a smooth here. And then comes the probability hill set. So this one is just appears to be bulking outside. And as you can see, somewhere at the top here, the images are not available, probably because the image is not available, or the cloud probability levels might have been greater than 35, because these are the mountainous region. So as this is the mountainous regions, they might have in the presence of clouds. So this is the very nice and easy way to create land covers. So I hope this video was helpful. So any comments are welcomed. Thank you.